Hey everybody, today we're going to be looking at 3.2 Day 1 notes, which is simplifying radicals. So a perfect square, you're probably familiar with perfect squares, you may have seen them before, but a perfect square is an integer that is the result of squaring a number. So a perfect cube, following along those same lines, is an integer that is the result of cubing a number. Okay, so integers are whole numbers. Our perfect squares are always going to be positive, as well as our perfect cubes. So let's go ahead and look at our perfect squares. So with a perfect square, there are actually two factors. You could have two positive numbers and two negative numbers. Right now, we're only focusing on the positives. So if 1 is our perfect square, 1 squared is 1. If 4 is the perfect square, we've got 2. And 3, 4. So basically our factors are the square root of our numbers. Okay, so if I take my perfect square and square root it, these numbers in this column are my factors. Now for perfect cubes, if I were to cube root each of these perfect cubes, I'd have 1, 2, 3, 4, 5, 6, and then down here is 10. Okay, those are our more popular cube roots that you will see. Okay, but you'll notice that we do have a gap there. So the next one, if we have 7, 8, and 9, 7 cubed, we have 343. 8 cubed is 512. And 9 cubed is 729. So a little less popular, but something that you may see from time to time. All right, so we're going to be using these perfect squares and perfect cubes and all of their factors to help us simplify radicals. But before we can simplify, there's a multiplication property of radicals that we need to be aware of. Basically, the multiplication property of radicals tells us that if I have the square root of two numbers that are being multiplied together, let's say a times b, what I can do is separate each of those into their own square root. That works for cube roots as well. So to simplify a radical, we want to find the largest perfect square factor. Then use the multiplication property to simplify. Okay, so let's look at these examples to help us fully simplify the radicals. So in example A, I have to fully simplify the square root of 75. So what I want to do is look at my perfect squares up above and find the largest perfect square that's going to divide evenly into 75. So it has to be anything from 64 and below. So the largest number that's going to divide into 75 is 25. Okay, so it's the square root of 25 times 3. I can use my multiplication property now to separate these. The square root of 25 times the square root of 3. The square root of 25 is 5 with the square root of 3 left over. And there's my simplified radical. Now number 2, I have the square root of 8. So the largest perfect square that's going to divide evenly into 8 is 4. It's 4 times 2. Now I use my multiplication property to separate those. Square root of 4 is 2, and I have my square root of 2 left over. Okay, number 3, we have the square root of 27. The largest perfect square that divides evenly into 27 is 9. That's 9 times 3. Split those into 2 radicals. Square root of 9 times the square root of 3. The square root of 9 is 3, and I have my root 3 left over. Okay, number 4, square root of 128. So this is going to be the square root of 64 times 2. So I have the square root of 64 times the square root of 2. Square root of 64 is 8, with a square root of 2 left over. Now, don't be afraid to use your calculator to divide by perfect squares. Okay, so right now, you're not going to look at the square root of 128 and know off the top of your head 64 divides into that. But if you keep practicing, use your calculator, you'll start to remember the perfect squares that go into each number. Okay, number 5, we have the square root of 30. So my factors of 30, let's see, we have 1 and 30, not really a perfect square, even though 1's a perfect square, but we can't do anything with it. 2 and 15, neither is a perfect square. 3 and 10, neither is a perfect square. 5 and 6, neither is a perfect square. So for number 5, this does not simplify. Okay, so that just kind of hangs out in front. All right, square root of 405. This one's going to be a little bit tougher. So what I would do is, because it's ending in a 5, I would divide it by 5, see what goes into it. So when I divide 405 by 5, I get 81 times 5. And 81 is a perfect square. Square root of 81 is 9, and I have that square root of 5 left over. Okay, now in 7 and 8, you'll notice that we have numbers in front. So we're going to go through simplifying when you already have a coefficient. So I'm going to break up the square root of 18. 18 is 9 times 2. Remember, this is 4 times 9 times 2. The square root of 9 times 2, I should say. Break up my square root. Square root of 9, square root of 2. Square root of 9 is 3. Square root of 2 is just the square root of 2. 4 times 3, I have 12 square root of 2. Okay, now in our next problem here, I have 2 root 80. I could do 8 and 10. Neither of those is a perfect square, though. So I'm going to divide by 4. I get 20, so I know I can still simplify that. I'm going to divide by 16, and I get 5. Okay, so 16 is my largest perfect square that divides into 80. So I have 2 times the square root of 16 times the square root of 5. Square root of 16 is 4. 2 times 4, I get 8 square root of 5. All right. Now, in our next examples, you'll see as we scroll through there, those are all cube roots. Okay, so we have to change our mindset just a little bit. Okay, now we're looking at these numbers with our perfect cubes and then the cube roots. So if I go back to number 9, I have the cube root of 250. So if I look at my perfect cubes, I can divide this by 125. Okay, so it's 125 times 2. The cube root of 125 times the cube root of 2. Cube root of 125 is 5, and I have a cube root of 2 left over. Now, you do need to make sure that you keep that 3 there by the radical. Otherwise, you're suggesting that it's a square root and not a cube root. Okay? All right. Now, in number 10, I have the cube root of 81. So we're going to take the cube root. Let's see, 81 is going to divide by 27. Okay, that's my largest perfect cube that divides into 81. So I have the cube root of 27 times the cube root of 3. Cube root of 27 is 3, and I have that cube root of 3 left over. Okay, if you want, pause the video and try 11 and 12. Now, for number 11, we have the cube root of 30. So 30 is 3 times 10, or 5 times 6. If we go back to our perfect cubes, none of these numbers divide evenly into 30 again, so that this does not simplify again. Okay, for the cube root of 40, that's going to be 8 times 5. 8 is our perfect cube, so I would have 2 cube root of 5. All right. When I have the cube root of 432, all right, let's see, what does 432 divide by? 216. Times 2. So the cube root of 216 times the cube root of 2. Now again, I just figured out what it was dividing by. I took 432 and kept dividing by all of our perfect cubes to see which one divides evenly, okay? So when I take the cube root of 216, I get 6, and I have a cube root of 2 left over. Number 14, we have that number in front. So we do this pretty much the same way that we would go about figuring out our other problems. So let's see, 135 ends in a 5. If I divide by 5, I get 27. You know, 27 is a perfect cube. So 7 cube root of 27 times the cube root of 5. Cube root of 27 is 3, with a cube root of 5 left over. 7 times 3, I have 21, with a cube root of 5. Okay, so there's simplifying perfect squares, or radicals with perfect squares, radicals with perfect cubes. If you guys have any questions or anything, please make sure you follow up in class. All right, have a good day.